One of those is our next keynote speaker, who has been a longtime participant in the MySQL user conference. Brian Aker is an HP fellow in the Cloud Services Organization. He's responsible for infrastructure engineering, technical operations, and customer satisfaction. Brian is also a core developer and member of the Drizzle Foundation board. He brings more than 22 years of IT experience to HP and has an extensive background in both technical and business leadership, along with in-depth experience in next-generation open-source technologies. Prior to joining HP, Brian was a distinguished engineer for Sun Microsystems, where his team was responsible for the next generation of MySQL and Drizzle. He also led efforts to improve memcached at Sun. He was co-author for the O'Reilly book on Slashcode and currently authors and maintains a number of open-source projects, including Drizzle, libmemcached, and Gearman. Brian has chaired a number of conferences, including the MySQL conference, which he did last year for us, and is a frequent public speaker. Please join me in welcoming Brian Aker to the podium. Good luck.
Let's see, is this working? Yeah, great. And after listening to that, I now know what I need to send to the HP marketing people and say, here's a few corrections in that bio that perhaps you send out. So I'm going to talk today about MySQL and the cloud ecosystem. I had gotten a phone call a couple months ago saying, hey, Brian, you come give a keynote. We have an opening piece. And I'm like, I'm not really sure. I don't spend as much time in the MySQL ecosystem as I once did. Well, come talk about it with regards to cloud. So, well, OK. So here's some basically notes that I had sitting around, thinking a little bit about where we're at with cloud in regards to MySQL. So here's my chicken scratch. Next slide. So who's HP? Why does HP even give a hoot about any of this stuff? HP ships one server every 15 seconds. We ship more Linux servers on the planet than anyone else. Why do we care? Well, databases are kind of core to all of that. And of that, by the way, it's kind of interesting. The one server every 15 seconds, one of those servers is actually Linux. It's always curious what the other three are. So let's look at this whole thing. Let's step back. Why did MySQL actually succeed in the first place? I mean, what does it matter? We've got all these machines. We have all of this stuff running. Why was it successful? And it's still amazingly successful. Well, first thing, it really had nothing to do with DDL, i.e. all your alter tables and all that stuff. That's all extremely slow still. I mean, we talk about it becoming better online operations, and it becomes better online operations. But it's still actually extremely slow. This is one of those debates, by the way. Some database vendor will say, oh, yeah, well, we have online DDL here. And you go, really? Is it completely online DDL? What about these? Oh, yeah, no, we have to pause in these moments. How many people here have ever had to sit around while some DDL is going on and watching your website grind to a halt, wondering if you're going to get a phone call from anybody at any moment? Like, oh, we'll do this at 2 a.m. Oh, no, we still have traffic nowadays. Turns out it's 24/7. So MySQL did not win by the fact that DDL became any faster. MySQL is DDL is about as much online, about as much as any other open source database when you get down to it. It didn't certainly win out because scale out is actually really tedious, actually. How many people here have set up replication in the room? Yeah. How many people have had replication fail on them in the room? Right, yeah. Scale out, kind of tedious. How many people have had to scratch their heads wondering okay, so if we make a replication bank and then we make another replication bank on that, somehow this thing is all going to scale out well, right? We'll just build multiple levels of replication, and then we discover that it turns out that replication is as fast as a disk write. So the more times you actually have replication, it's just in number of writes. It's really not actually much faster. So MySQL did not win because really scale out became a whole lot easier. Why MySQL won really was because it was actually easy to install. If anybody remember that first slide where I have /U01, does anybody remember what /U01 was? So this is a generation of folks around, yeah, one person in the front. One generation of folks who never learned what databases were like before MySQL. When you would put the installer CD in, when you had an installer CD, it wasn't a tape, and you would sit there and it would ask you a bazillion little questions, and it would have to force you to repartition your disks and all this other stuff that really made no sense whatsoever, and you just kind of kept hitting the return button, hoping the default answers were okay. I mean, most people's experience with MySQL is now what your database experience was. It came on your Linux distribution, or if you're a Windows user, you downloaded it, you double-clicked, it ran. That was your experience, and from that experience, you actually got interested in databases. If anything, the thing that MySQL I think most provided to the industry was to get around the excuses of, well, databases are too complicated. They'll be really hard to install. You really need to have us come in and install it for you. Like, all of that went away. MySQL removed that. So suddenly SQL databases became essentially a can opener. Turn it. Everybody understands it. So, and from that came LambStack. LambStack was really kind of neat if you think about it. Like, here you had a whole set of things that kind of pulled one another together. And it's not always like obvious to folks, people like, in some ways, the accidents that occurred in this. Apache came with what? Either it came with PHP installed, or PHP was very, very easy to install. You didn't have to do anything. And Apache, it'd start up and running. Sure, if you started changing the configuration files, you might sit there forever wondering, like, config test. Oh, what did I do wrong? Why didn't this thing authenticate? What was this directory inside location, auth access? Oh, yeah, a little hard to deal with. But it all pretty much worked off the bat. And PHP made a lovely mistake early on, which they regretted for a long time, that users loved. And that was essentially this. When they first shipped PHP, they shipped MySQL default compiled into it. It was actually defaultly compiled into it. Think about that. Like, it made it simple for people to use. It was ease. Why did they hate this long term? Because of the dependency hell that this actually created, because of all of the problems with having to support databases later on. Like, this is one they tried to spend a lot of effort trying to back out of it as a decision. But it actually, that ease of use is what enabled everybody to use the thing. It's kind of funny to think about it. And all these things sitting on top of Linux. And Linux, compared to what we had in the very beginning, Linux was actually pretty easy to install. So all of this became LAMP. And so we looked at forward and saw for about a decade this LAMP stack. And I don't know how many times I've sat in rooms where people are like, okay, so it's LAMP, right? So if we remove the word L, we could put, say, something like Solaris in it. And then we'd have SAMP. And you'd sit in a room and go, that kind of sounds like SAP, right? No, sorry. Anyway, like, it didn't really work. You had people, Microsoft trying to insert, Microsoft, IIS, and then we try to, everybody trying to, jumble these letters up and put in their own product. And really, like, this is what stood out the entire time. And what everybody was missing, the point is, everybody's trying to, like, get on to the next piece. Wasn't about this one little configuration that dominated for a decade. Because this is what happened. And by the way, I'm using slides from HP things mostly, not only because I'm employed, but also because, well, I know I can use them and not get, like, sued. So this right here, this is what started to happening. How many people went and, like, realized the first time that they went from, like, one server to dozens of servers? Like, who's had the experience of going, like, okay, we got 1, 2 servers, and then suddenly realize they have blocks of servers here? Okay, yeah. So what happened? And then you're like, okay, we can't really keep installing these things again and again and again. Like, I don't really want to sit in the data center losing my hearing, trying to get a USB stick in, and hoping these things will boot, and trying to figure out what went wrong. Or, worst mistake is, you didn't learn to actually put, disks in the machine that could easily pop out. So you're trying to, like, wedge the suckers out with, like, a screwdriver or a pizza pan, trying to slide machines out because you didn't, like, stack them correctly. So we moved on to these things. Well, so here's what you're in problem. What are these things? Well, eventually you end up with these things. Notice that's doors at the bottom. This is an Ecopod. These giant things actually take lots and lots of those previous things and then ship them. The Ecopod, here's our statement of actual CPU now. So it's not like I have a box or I have 8 cores in my box. You're talking about, I think there's, 144,000 cores in one particular one, like things like that. We start growing out and out and out. LAMP starts to look kind of small and difficult. Like, how do we get LAMP to work on this whole thing? It's not like all the marketing slides that say, we'll auto-scale, we'll whatever. Like, what does that mean? How does my application supposed to auto-scale? It only knows how to connect to one thing. So, and then what do? Now we're moving into this kind of stuff. These are Moonshot boxes. Suddenly you take those big, long servers, you start packing them into these little cartridges, and you start sticking these things in those big, giant suckers. Okay, at that point, let me take a guess. Okay, you're not going to stand around anymore with a little USB stick, hoping to God you get done by, the time, like, whatever, amount of radiation around these things eventually, cook you. So what do we got? This is where actually we see something going forward. This is OpenStack. This is one of, probably much the dominant one, of actually the solutions for this. How do we take lots and lots and lots of servers and look at them as a single unit? In the same we looked at a stack and we came with LAMP. This is the next piece. And in the next piece, this is where we start talking about cloud. And cloud, you can see, there's a little clarity now, right in the middle there. We're starting to actually see what all this means instead of just the hyperbole and everything else going on. So this was a couple of years, this is about a little over a year ago. This was actually what OpenStack looked like. OpenStack was Nova, Glance, and Swift. What is this? This is compute. This is actually object storage. Here's the very basics of it. In the same way that when we first booted a Linux box, we had, look, here's a prompt. What can we do with it? And what are we starting to see? Well, fast forward a little further forward. This year, what do we start to see? We see Nova, Glance, Horizon, Keystone, Swift. We actually see this whole stack starting to build out. And as we see this stack starting to build out, we're starting to see all these components. And we're starting to see what is LAMP actually form right now. And when we jump a little bit forward, we can start to see this. This actually starts to fill out what the other components. Within HP Cloud right now, we did a survey internally. We discovered that 32 components make up actually what it takes to run a public cloud. That's kind of an interesting number. 32, no, that's a lot more than what, say, we're sticking on a single box. And one of the what's one of the things at the core? It's interesting, of course. Same thing we always go back to. It's the database. The database is the core component that actually runs all this stuff. Our state machines, how do we, what's going on? Not the actions, we can see those in event queues, but the database. So this is something that about a year plus ago, both Rackspace and HP started looking at and investing in. Because how do we take this piece, compute, networks, and storage, and turn something basic in, and do something a little more, which then got us into this world. And this is Red Dwarf. It's interesting to go out and look and see, like, out in the showroom and other places, you can start to see where, like, certain commodity ideas start popping up. And one of those, of course, is database as a service. It's interesting, as I probably will, like, poke Matt a little later on, looking at his slides. Like, the relational database service market is actually a lot bigger in the cloud than what we seem to think it is. By the way, if you want to figure out the number, take a look at, like, IP addresses signed out by, like, Amazon with, like, MySQL instances, and start looking at, like, the distances between IP addresses. You can start to kind of see and get an idea of actually how many they've got running on in there. Can do that pretty much with all the vendors at this point. But that even doesn't include what's actually running inside of those clouds. I had someone from Microsoft that, asked me about this, and they were like, well, we're kind of discovering that, 58% of our instances actually have MySQL on them inside our cloud. We were surprised by that. And it's like, why are you surprised at that? It's easy to install. So in our world, what we see is actually Red Dwarf. We're trying to have it come out with the open source component, commoditize this out so that everybody can actually have database as service. Well, what does that mean? That means suddenly all of this stuff you start to see, the database as service that you don't like doing. Like, who wants to really deal with setting up replication yet again? Who wants to figure out how to handle this failover part yet again? I mean, go in the showroom, look around, let different people what they're doing. It's all a very similar idea right now. This is the idea that nobody really wants to be managing their database. And early on when we started the service with HP, I actually made a point of, like, calling a few customers out of, like, so are you having problems with the product? What's happening? The thing I was surprised about? We not only had the customers who were just signing up because, they were trying to figure out how to move their IT out more like a dev test, but I would also run across single users who just didn't even want to touch the database and install it on Windows. Install it on their local box. People don't want to do that. People want to actually have something serviced for them. And when we're getting into the cloud, it's all about moving past these, like, well, how do I set up these components? It's about actually getting down to your application and running your application, and no longer as much about how do I get my IT set up. People don't want to set up IT. Because, this environment right here, who's out here that actually tried to ever set up something like this? Like, they've had these giant diagrams, and this is how all of this is going to work. Like, it gets tedious. It really is. What you want to do is say, give me 10 databases, I want them replicated, I'm done. And then what you want to do is you want to move on to your application framework. This is what the cloud's about. The cloud is about, interestingly enough, in this regards, taking MySQL, which was already easy to use, but not so easy to use in the whole scale-out thing, and turning it into something which is actually ease of use. And by ease of use, it means, this isn't quite the right page on the horizon in frame. I want to go to a web page. I want to click on things. I don't want to go down and look at the myCNF file anymore. I don't want to deal with set master or any of this other stuff. This is about ease of use. Similar story as what it is in the very beginning. So what's the next thing in this whole thing? This is kind of the interesting piece. Like, what is actually happening beyond what, okay, I got a database up here. What do we need to be doing? Well, one thing. Look out and see what we're starting to see. You got things like Galera out there. Galera is pretty cool. Galera we see as usage case both in above the cloud, i.e., in the cloud, but also in below the cloud. In the cloud, what do we see with Galera? We see Galera being something that allows people to set up things in multiple regions and handle that failover without any problem. What do we see it in the under the cloud? If I go through and look at slides between different vendors, I'm almost inevitably finding Galera or a couple of other solutions always at the core to how we're even building out clouds. And notice, by the way, Galera's kind of replication. This is not the read, the read-only scale-out replication stuff. That was great a decade plus ago. You had me, Zawadney and other folks trying to make that stuff work, to make Yahoo /dot work. But it's not anything anymore that really people should be looking at as a solution. It has problems. So things like Galera, above the cloud and below the cloud. What's the real cool thing about this? For the ones of you who are working on below the cloud, building out, we now have solutions like this that will actually help us do HA. For the ones of you in the cloud, well, that means you're actually going to be using it in the cloud, but it's going to be great because what? You're not going to have to be concerned about setting this thing up. It's going to be what's going to be working on behind the scenes. Other things we see, for the first time ever, I actually started seeing MySQL cluster show up under the cloud. That's kind of neat to see. And I've started seeing it in the cloud. Cluster traditionally has been an extremely difficult product to actually set up and use. I remember the very first phone calls of people who tried to use it and many people who got burned on it so badly they wouldn't touch it again. We start to see ease of use all this. All of this becomes simple. And we also start seeing all these databases, they're all kind of similar enough. They kind of look like each other. They're not quite the same thing. They don't always exactly know, but they're actually similar enough nowadays. And with that, with regards, I look at things like Galera right now, and I think, okay, this is actually why, MySQL for the next 5-8 years is probably going to continue to be dominant. That's obvious. It just bought itself, another 5-8 years of relevancy out of these technologies. But the databases are actually becoming similar enough. So here, for instance, here's Cassandra. Cassandra by itself, go look and take a look at, for instance, DataStax and look at their SQL interface. Those SQL interfaces are becoming similar enough now that you can start to see how that could just actually be to replace MySQL in an almost drop-in fashion. It's not there quite yet, but you kind of start seeing this stuff. The NoSQL movement in the beginning was really looking at what, in my opinion, the solution of two things. DDL was problematic. Nobody wanted to deal with DDL. Nobody minds the schema most of the time if the alterations to the schema can be done in an online, fast manner that they don't need to worry about. Sure, you can have blobs, you can have places that are formless, but for the most part, people kind of like schema. So if you can remove that problem, people will actually come back to it. Second piece is the scale out. Scale out of the database is extremely, extremely hard. If you can remove those, you remove that boundaries. This is what NoSQL started to solve, is these two problems. But what do we see in most of the NoSQL solutions? We start seeing a push towards actually now doing SQL. And as they're doing SQL, I think we'll actually see things that are actually becoming, we'll end up seeing an interesting emergence that'll occur. So here are my thoughts currently on the cloud. Hope you enjoy them. If you have any other questions, please feel free to ask me later on. Thanks very much. Bye.